Lesson 12.7 looks at the surface area of spheres. You'll learn to recognize and define basic properties of spheres and find the surface area of spheres. How do manufacturers of sports equipment use the surface areas of spheres? The sports equipment industry has grown significantly in recent years because people are engaging in more physical activities. Balls are used in many sports such as golf, basketball, baseball, and soccer. Some are hollow while others have solid inner cores. Each ball is identifiable by its design, texture, color, and size. To visualize a sphere, consider infinitely many congruent circles in space, all with the same point for their center. Considered together, these circles form a sphere. In space, a sphere is a locus of all points that are given distance from a point called its center. There are several special segments and lines related to spheres. A segment with endpoints that are the center of the sphere and a point on the sphere is called a radius of the sphere. In the figure, DC, DA, and DB are radii. A chord of the sphere is a segment with endpoints that are points on the sphere. In the figure, GF and AB are chords. A chord that contains the center of the sphere is a diameter of the sphere. In the figure, AB is a diameter. A tangent to a sphere is a line that intersects the sphere in exactly one point. In the figure, line GH is a tangent to the sphere at point E. The intersection of a plane and a sphere can be a point or a circle. When a plane intersects a sphere so that it contains the center of the sphere, the intersection is called a great circle. A great circle has the same center as the sphere, and its radii are also the radii of the sphere. So that would be the largest circle we could cut out as a cross-section of the sphere. And of course, a sphere has an infinite number of great circles that can be cut out of it. Each great circle separates a sphere into two congruent halves, each called a hemisphere. Note that a hemisphere has a circular base. In the figure, O is the center of the sphere, and plane P intersects the sphere in circle R. If OR equals 6 and OS equals 14 centimeters, find RS. Well, that's going to be a right angle. So we can use Pythagorean theorem. 6 squared plus b squared equals 14 squared, so 36 plus b squared is 196. Subtract 36 from both sides of the equation, and I have b squared equals 160. And if we take the square root of both sides, b is going to be about 12.6 if we round to the nearest hundredth. Once again, our friend Pythagorean theorem comes to the rescue. If a sphere has a surface area of t square units and a radius of r units, then t equals 4 pi r squared, which happens to be 4 times the area of the great circle. So if they ask us to find the surface area of a sphere given the great circle with an area of approximately 907.9 square centimeters, all I have to do is take that number that they gave me and multiply it by 4, and I'm going to get about 3,631 and 6/10 square centimeters. Find the surface area of a hemisphere with a radius of 3.8 inches. Have formula can use. Since it's a hemisphere, we're going to have to take our sphere and divide it by 2, so 4 pi r squared times a half, and then add the great circle. So I'm going to substitute in 4 pi times my radius is 3.8, it is squared, plus pi times my radius is 3.8, and it is squared. And I type that in the calculator, and I get approximately 136.1 square inches. Find the surface area of a ball with circumference of 24 inches to determine how much leather is needed to make the ball. So they gave us the circumference. We're going to have to work backwards to find the radius, which is not a big deal. We're just going to divide both sides by 2 pi. The 2 works out well. It's 12. I'm stuck with the pi. So it's exactly 12 over pi, which is approximately, when I use the calculator, 3.8. And now we're going to take the 3.8 and plug it into our surface area formula. So surface area is 4 pi r squared. So 4 pi times the radius we found was about 3.8. And we plug it into the magic of the calculator and we get about 183.3. And our units were inches and they are squared. The set of all points in space, a given distance from one point, is a sphere. The surface area of a sphere is 4 pi r squared, where r is the radius of the sphere.